Thanks for coming, everyone. For some reason, I thought I gave the club a talk last year, but it was the year before. Just recently, as you saw, in 2023, I spent some time in the US, and I was invited by the International Planetarian Society. I ended up spending 62 days in the US, and I drove across the country and got to do a number of lectures throughout the country. Incidentally, if you have any questions, I'm happy to answer questions as we go along as well, so please feel free. So one of the places I worked at for a couple of weeks was the Lowell Observatory in Flagstaff, Arizona. And they have quite a history. For example, Pluto was discovered from this observatory. And I'll say a little bit about it towards the end. But while I was working there, I'd been to the US 26 years before, and I'd been to Meteor Crater, which is in that region as well. But I've not been to two places I'm going to mention tonight: Sunset Crater Volcanic Monument, which I'd heard of, but I thought, I won't worry about it the first time I went there because I was there for astronomy. And I was so glad I went to this place this time. Anyway, so let me just make sure my pointer is going to work here. That's not changing, so let's try it manually. Oh, that's interesting. So anyway, volcanism is fundamental to the formation of many features throughout the solar system. And here we can see examples of, this is Io, this is one of the moons of Jupiter. Jupiter now has 95 different moons. We can see a volcanic plume here. I better check my time that I started. Two volcanoes on the surface of Venus here. And this comes from Magellan space probe data. We've got Mahat Mons, which is named after the Egyptian goddess of truth and justice. And this particular volcano is the second tallest mountain on Venus, and that's about 5 kilometres above the surrounding plain in this area. Looking down on Sapphis Mons, which is named after a Canaanite sun goddess. Again, looking down on a volcano, scale from there to there is about 400 kilometres, and it's about 1.5 kilometres high. And Venus, throughout its history, has been very volcanically active. And with that, we can't leave out Olympus Mons, which is the tallest volcano in the solar system. This volcano is about 25 kilometres high. So it's nearly 3 times the height of Mount Everest. And so if we could, and it's a giant shield volcano, so it's got a very low profile, it doesn't come to a sharp peak. And if we could put this where Mount Lofty is, it would be 34 times higher than Mount Lofty. So it's an incredibly large feature. All right, that's good, that's working. And I'm not going to go into a great explanation on volcanoes, but we know volcanoes mainly occur around tectonic plate boundaries, particularly around the Pacific Rim. We've had some very good talks, introductory talks at the start by Kim and Peter recently on the different types of volcanoes. But as you can see, it's basically just an opening in the Earth's crust where gases and volcanic ash and material escapes onto the surface. The earliest descriptions, or some of the earliest descriptions we have of volcanoes, come from Pliny the Younger. And you may have heard of Pliny the Elder. Pliny the Elder was a writer in ancient Rome, and his nephew was Pliny the Younger. And he actually wrote one of the first descriptions of a volcanic eruption. And certainly in this region here, he wrote about Vesuvius when it erupted in AD 79. Now, he was about 17 or 18 years of age when he wrote, I beg your pardon, when the eruption happened, but he wrote about the eruption about 25 years later. And in that description, he described earthquakes preceding the eruption, the cloud of ash coming out, pyroclastic flow, so the ashen material coming down the side of the volcano. In fact, his uncle, Pliny the Elder, died in this eruption at the age of 56. He was going to rescue a female friend, and he was caught up in that eruption at the time. So we were starting to move from we thought about earthquake gods as causing, everything. Where we're starting to get scientific descriptions around this time about what was happening with volcanoes. So I'm particularly talking about this region of the United States, and you'll know that there are 50 US states, 48 contiguous states, so 48 states in this area here, but in particular the Colorado Plateau. Now when I went there years ago, I never realised that all of around Flagstaff, that area, was all volcanic. I thought it was very beautiful and the mountains were nice, but I didn't realise until I went this time in 2023 that just about every hill and mountain you look at is a volcanic landform of some type. All right, so basically my trip this time, I came into LA, I gave some lectures here, and I basically drove across here, and I'm just looking for Flagstaff is here. All right, and that was about, I've got another slide, I'll explain that in a sec, but my real destination was Tennessee because this was where this big conference was, and I finished up in Pennsylvania and flying back here, cutting a long story short. So when I went years ago with a friend, we drove through 18 states. This time I drove through 12 states. And look, I highly recommend driving. It's the only way to see a country. It's really nice seeing things from the air, but there are so many interesting places. I'd be here all night if I showed you everything I saw on the way. I took 7,000 photos this trip in 62 days. So, there's so many interesting things that you see on the way, museums, landforms, all kinds of things on the way. So I was staying a couple of hours south of LA in Fallbrook, and this drive, when you look at the maps, it's 7 hours, 15 minutes, but it took me around 8. I had planned to cut it in half, but sometimes you get on the road and you think, oh, I'm just going to keep going. So I actually got to my destination a day early, so I booked into another motel a day early. Probably unwise, because my last 2 hours I was driving at night, and there were lots of dead deer on the road, so it's a bit like kangaroos here. Everywhere you drive there, if you're in an area like this, you've got white-tailed deer, and I thought, probably wouldn't do that again, probably not a wise idea. Anyway, so my destination at this point, near Sunset Crater, was Flagstaff, Arizona. Now, Flagstaff is a pretty big town now, or city. It's got a population of about 76,000 people. About 10,000 of that planet identify as Native American. So there's a very high Native American population as well. It's very close to the Navajo Nation and the Hopi Nation and a number of different Indian groups in this area. So to drive out to Sunset Crater, what had happened was I was working with a Native American group at Lowell Observatory, and I kind of asked some of them, hey, look, what's Sunset Crater like? Is it worth driving out? And they said, oh, it's okay if you want to look at a few volcanic rocks in here, here and there, but it wasn't what I expected at all. It was so spectacular. And even if you're not a geologist and not interested in geology that much, I would go out just for the scenery. It's beautiful scenery in that region as well. When you look at it from Flagstaff, and I don't know how many of you may have been there before, you have a number of mountains, and they're all part of the San Francisco volcanic field. The Franciscan monks called them Sierra Sin Agua, place without water, where the Native Americans from the area say the opposite. They basically say this is the area where there is water and so on. But I hadn't realised, I will show you a photo looking back at these. So this area here is the rim of a giant stratovolcano that blew its top. And it blew its top about 500,000 years ago or so. So this area, this volcanic field, has been created about 600 different volcanic features. So cinder cones, big volcanoes. It is absolutely littered. And so it's been associated with a hotspot. With tectonic plates, where the plates meet, we often have lots of volcanoes, but we also have hotspots underneath the plates, places like Hawaii, while we have the Hawaiian Islands and so on. So the place I haven't visited is this place, so this is on the bucket list. So this time, when I went many years ago, I went to the Grand Canyon. I thought, shall I go back? And I hummed and hawed. I thought, no, I'll go and check this place out. And I was so glad that I went in. And this leads straight into the Wupatki National Monument as well. So when I checked in a day early and standing on my balcony, this is the mountain range you see right next to Flagstaff. And what I hadn't realised the first time I went was this is actually the rim of a stratovolcano that had blown itself to bits about 500,000 years ago or so. This is more of a topographical map in the visitor centre, so you can see all these features here are all volcanic cinder cones or old volcanoes, rims. It is just littered. There's 4,700 square kilometres of volcanic features in this region. It's just everywhere. So if I ever go back there, I'm going to hook up with one of the local geologists and just spend a week out there. We can easily spend a week out there investigating. The famous meteor craters off in this direction, and so you head out of here, and it's only about a half an hour to reach the entrance to Sunset Crater National Park, and as I said, it's well worth the visit to this place. So they have a nice little visitor centre. It's about $25 US to go into the national park, so about $38 Australian, worth every cent. The pass lasts you for a week. I planned to spend about an hour or two out there. 7 hours I was struggling to get back after 7 hours, and I wanted to get back because a colleague was giving an astronomy lecture, plus it was going to get dark. So the pass lasts you for a week, and this gives you entry to Wupatki National Monument, which is joined on, and also the Sunset Crater Volcanic National Monument. So this is looking back on those peaks. So the photo earlier was over here, and this is the remains. These are the San Francisco peaks, and this is the rim of a volcano that blew itself up about 500,000 years or so ago. And this park is extremely well signposted. So it has great signage regarding the history, the Native American history, the geological history, the European history, and so on. And so when Franciscan monks went through here in the 1600s, as I mentioned, they called it Sierra Sin Agua, place without water. Now, this has nothing to do with the city of San Francisco. They were named this 147 years before San Francisco, the city, got its name. Because when I was there, I thought, oh, there must be some sort of fault line or connection to San Francisco, but there was no connection between the two. So this is looking back at the peaks, and I'm standing around here, and you'll see the Sunset Crater. So ponderosa pine, this is all part of the Qa'na National Forest. It's a beautiful area. And here's our volcano. This is a cinder cone. It rises from sea level about 2,500 metres. Above the surrounding plain, it's about 305 metres. All right, so it's a cinder cone. It's erupted material, probably a very short eruption, anything from a few months to a couple of years, and then it's become dormant. And at the end of the eruption, you've had magma welling up, and then it comes out as lava, and you've got these lava rivers that lead off from this volcano, which I'll show you a little bit about. Here's an artist's rendition of how the volcano once would have looked. Depending on the source, some sources say it may have been about 18,000 feet or 16,000 feet, so it's currently a little over 12,000 feet. So some sources say it may have been the tallest volcano in the last 6 million years in the US, and so on. So it's a big deal. And they think that it may have exploded somewhat like Mount St. Helens. There have been preceding earthquakes, and this stuff's blown out along here, and it's all collapsed and gone boom. These stratovolcanoes tend to be more explosive in their eruptions, where the cinder cones, the stuff's very sticky, viscous, and it flows out fairly slowly in comparison. All right. As I said, I'm not going to, there's a diagram for you. I'm not going to go into a big explanation about stratovolcanoes because we've had some fairly good talks based on this material, but they tend to have high peaks, be very sharp, as opposed to shield volcanoes and cinder cones and so on. And look, there was stuff I looked at They have all of these layers of strata named, and it's very interesting, different ages and so on, which we're not going into tonight. So as I said, even if you're not interested in geology, it's a beautiful area just to go for scenery. You get native deer in the area, you do get bears around there, although I didn't see any bears. You get bobcat and various species of birds and so on. So when the important thing with this volcano is this erupted only a little over 900 years ago, less than 1,000. So you guys will know, astronomers and geologists, we talk in millions and billions of years all the time. And I know sometimes when I'm at the planetarium and talking about, something that's, going to happen in a million years, people are like, oh, that's forever. Where, 900 years, less than 1,000 years, is very young. Most of you will know that we have the youngest volcanics in our state at 4,700, roughly down at Mount Shank and Mount Gambier. So less than 1,000 is very young. And, and it's still very blackened on the side of this feature as well. As I said, it's about 305 metres. So here's an aerial shot, not taken by me. I must really praise the National Park Service in the US. The roads are perfect, the signage is perfect, everything's really, really well maintained. And the caldera, the crater at the top. And so you come in on the road here, and there's a car park back here, and you can kind of walk out here. Now, you're not allowed to climb this volcano. Now, I'll tell you a little bit more about that when I show you a few other shots. But I wasn't that fussed. The crater is less than 1 kilometre across. It's about 91 metres deep. But you can drive right around the rim. There's a Google Earth type shot. And the reason I show you this particular shot is the crater is here. There's a smaller one there. I think that was a Leary crater. But in particular, I want you to take note of the stuff that oozed out at the bottom and formed these dried up lava flows of basaltic rock. But in particular, this bit here. Now, this is known as the Bonito lava flow. Bonito is Spanish for beautiful. And this was the stuff that blew me away when I saw it. So you're driving here. So I was expecting a little bit like, I've been to New Zealand and I've been obviously down to Mount Shank, and you drive along and you might see where they've dug up some outcrops. So I was expecting to see something like that, a little bit of volcanic rock here and there. But there was a lot more than I expected to see. And this was it. And a photo does not do it justice, I swear. And it's one of those moments where I was driving along the road and I did a, what? You do a double take. And this river of solidified lava, again, is over less than 1,000 years old. To give you an idea, from there to there, if you were to go to the Murray River and find the very widest spot, it's a bit like that, the width. It's about 30 metres deep in the centre, they think. And so this lava came out and fairly slowly, and I think they call it pasty lava. I'm happy to be correct on the terms, but it rolls out and then it splits apart and becomes what they call clinkers. So this rock, in fact, I've got a rock in my bag I meant to pull out earlier. This stuff is very, very sharp. So if you brush against this, so it's a basaltic rock, but if you brush against it, you cut yourself up. It's very sharp. Here's a bit to have a look I brought back. I wanted to bring tons of this stuff back, but it wouldn't fit in my suitcase. My suitcase is already packed. And it's bad enough if you're a full-time geologist wanting to bring tons of stuff back, but even I won't. And so it's very sharp, and you can have a look at this at the end. So as I said, it just doesn't do it justice. It's really amazing to see. And no matter what photos, I think it still looks good in the photos there, but to see it, and I was talking to one lady there, and she said, people go to Hawaii to see this. Now, Hawaii is still very active, but, and she said, we've got this all in Arizona. And I never realised stuff like this was there in Arizona before. And that's the great thing. She took a photo for me. There are a few paths, so there's a few stops we can pull over, and they've got signage explaining the history and the geology, and you can walk through here. Now, I didn't because, as I said, I spent 7 hours out there as it was. If I'd done some of these walks, I would have been there for days. days. But just to see a solidified river of lava was amazing. I've not seen anything like that before. And I know there are many countries have features like this. You can see where people are walking through here. There's the actual volcano in the background, Sunset Crater, and there's a car park up here. The rim of the crater, when the sun's setting and so on, there's the iron has oxidised and it has a little bit of a red colour. So John Wesley Powell, who was one of the early explorers in this area, in fact he's amazing in his own right, he was the first guy to travel down the Colorado River, I believe, first European to travel down the Colorado River. And he said it looked like a sunset when he was looking at it. So it ended up getting called Sunset Crater anyway. So even though you can't walk into the crater or up to the top, you get right onto the edge of the crater and you can get great photos. As I said, the pathways are really good. They've got signage everywhere. So if you've got a poor understanding of geology, probably like myself, you can learn all about it. Now, excuse me, see these lanes here, they stopped walking up the crater in 1973, and that was because the tephra, the ashen material, was, they had a path like this, but apparently it spread right out to 6 metres, it was just collapsing. And so they stopped people from going up there because they wanted to preserve it. The other thing was, in 1928, Hollywood came in and they said, we want to make a movie. And so Hollywood's idea, what they wanted to do was they wanted to put as much explosives as they could, TNT, into the centre of the crater, and they wanted to create an artificial erupting crater, an avalanche and so on. Now, and this was in 1928, they were going to make this movie. I think the movie was called Avalanche. And so the locals were horrified. They said, we don't want you blowing this thing to bits. And so, for one, they stopped the walking up here, as I said, in 73. And then in 1930, the president, whose name escapes me, he made it officially a national park, which is a fantastic thing because it's preserved a beautiful area of wilderness and some amazing geology. Wouldn't we love a field geology trip there? It's just like, it's really, really good. We'd be right in our element there. These, I think this is called a squeeze up. You've had like lava rolling out and the stuff dries out and it splits apart. And some of these features are quite large. So again, very good explanations of what happened in this area when this erupted about less than 1,000 years ago. You don't see the big, tall, majestic ponderosa pines close to the crater. Now, when this thing erupted, Native Americans, the Sinagua people and Hopi ancestors and Navajo lived in these regions. So we know about the dates because they obviously had warning in the form of earthquakes and maybe a few smaller eruptions because they grabbed the logs they used in their homes and that and moved further away from the crater. And through dendrochronology, we've been able to analyse, and they've been able to, looking at the ash, they've been able to analyse and work out dates as a result. And so I always assumed when I was younger that if you've got volcanic ash and material, perfect for agriculture. Not if you're close to the things. These things grow poorly because, really close, it's about 3 metres thick. However, when you get down onto the plains where it's more arid, and if you get the soil and it's about 3 centimetres thick of ash, that's perfect for growing because it helps absorb water in the desert environment. And so that's what the local Puebloan cultures, the early indigenous people did. They were able to, it became very prosperous for a couple of 100 years. This is John Wesley A'ā. He ran an expedition through here between 1829 and 1897, I think it was, actually. And anyway, it was in the late 1800s. And as I said, he was the first European to take an expedition down the Colorado River. But he named the crater and he made connections with the indigenous populations there. And he was the second second director of the US Geological Survey as well. He was followed by Walcott after that. He's an interesting character to read about. When the Civil War started in 1861, he rushed in and volunteered, and he got his arm blown off in the Battle of Shiloh. So he's got one arm there, but he used to still roam around the US outback, if you like, and work. And he did amazing work on geology and ethnology, so looking at cultures. But unfortunately, he was also a product of the day, where he said Native Americans need to be assimilated, they need to be Christianised. So he's kind of loved by some and hated by others as a result. And there he is, leaning on his stump, chatting to one of the Native Americans there as well. Leading up to before putting man on the moon in 1969, we really didn't know what to expect, what the surface of the moon was like. And I know as a kid growing up watching science fiction movies like First Man in the Moon and movies like that, where the surface of the moon, there was sharp, jagged rocks and nothing like, I remember seeing as a kid the first images of the surface, and it's smooth and very kind of dusty. So they did a lot of training in this area, and there's one of the astronauts with the San Francisco peaks in the background. All right, and they actually walked and drove over some of this jagged stuff. This is Harrison Schmidt and Eugene Cernan. Eugene Cernan was the last man to walk on the moon. So we often know who the first guy was. He was the last guy. And Apollo 11 spent about 2.5 hours on the surface of the moon. These guys spent about 75 hours on the surface of the moon working. So Eugene Cernan and Harrison Schmitt. Now Harrison Schmitt was the only scientist to have gone to the moon out of the 12 astronauts that walked on the moon. And he, of course, was a geologist. He'd studied geology, and he's still going. He's in Albuquerque. In fact, I missed him by a day when I went to the museum. He's about 90 now, so he's still with us. But he taught us some great things about the moon. So they did all their studying there and rehearsing in that area. The local group, now this area by the crater there is sacred to 13 different Native American groups. All right, in particular the Navajo, the Hopi, I think it's the Western, Southeast, no, anyway, it doesn't matter. It's one of the boundaries of the Navajo. The Navajo Nation is nearby. There are 160,000 people in the Navajo Nation. It's a very big area. But the Katsinas, we often translate as Kachina in English, which is apparently not correct. But they were the spirits who'd gone to the underworld, and they favoured the villagers, and they would have offerings and so on. And so they believed that the Katsinas would come out of the San Francisco peaks, and they would help with the growth of crops and all of that kind of stuff. And they'd have performed dances, and they'd make Katsina dolls and so on. And then they would go back via the Sunset Crater. All right, this lovely painting by the gentleman just there. And they make these lovely dolls. You can actually buy these now. They're a big tourist thing. And I believe the tradition originates more with the Hopi and the Zuni, and the Navajo have adopted it more since the 1800s, particularly from a tourist point of view. Again, there's all sorts of explanations. The Navajo dolls tend to be more block-like and not have as much detail, where the Hopi dolls tend to have a lot more detailed carving on them. And you can see this one, this is in the museum, 2,500 US, so what's that, about a little under 4,000 Australian? It's about that big. But they are really decorative, really pretty, and you can get cheap ones too for a couple of $100s. So these were very important spirit deities relating to the crater as well. In the museums there, they've got all kinds of things they found in some of the pit houses after the eruption. They find, don't ask me what stone this is, but arrowheads, pottery, and the other thing with the local groups, and so there's been a history in particular of a couple of thousand years of people in the area, but in particular around Wupatki, which I'll show you, a couple of hundred years there they were there in that area. But they put ash from the Sunset Crater eruption into their pottery. And they've looked at it and chemically analysed it, and it's only from that eruption. So whether there's obviously something significant about that, maybe because they witnessed that eruption. Moving on to Wupatki, you drive straight into this. I don't know why it's separate, but this was declared a national monument earlier, back in 1924, so 6 years before Sunset Crater, and there are native Puebloans, Pueblo buildings, I beg your pardon, in this area. It's, so you go from where the San Francisco peaks are, where there's all the ponderosa pine forest, and then as you come down, you come onto really dry, red desert. And this is on a sandstone, a red sandstone called the Hopi Formation, which was laid down back during the Triassic period a couple 100 million years ago. And there's lots of this. And the great thing for me was the weather was perfect. It was sunny. The whole 62 days I was in the US, I think it rained for 2 days. So that brings out, the light brings out the nice colour in the buildings that we can see here. And the great thing is you can walk through all of this as well. They let you walk through it. Now, I've done a lot of travelling in Australia, and what I really noticed about this area was there's no graffiti. There doesn't seem to be any vandalism. Everywhere you go in Australia, whether Aboriginal petroglyphs or painting, there just seems to be graffiti and damage done. So I don't know whether it's a different, they think about things differently, whether they have rangers patrol more regular, or if there is graffiti, they wipe it off. But certainly it was far better protected. This is the Wupatki National Monument. This building once in this region housed about 300 to 400 people. So it was a trade centre. The climate was wetter back then. So we're talking back about 900 to 1,000 years ago. It was much wetter, much better for agriculture. And so they built these lovely Puebloan buildings, which we still have remains of to this day. And this would have been a 3-storey building, so it was quite tall. The building's stone is again from the Hopi Formation. As you see, this area is situated between the Painted Desert and the Ponderosa Highlands. Every time I hear Ponderosa, I think of Bonanza. I grew up in that generation. But again, you know, it is amazing. You change from really green area to really dry area fairly quickly as you descend. Alexander von Humboldt did a lot of research on the way you get different systems as you come down a mountain over time in the early days. And this is how it would look if we could put an artist's drawing over the top. So as I said, it housed about 300 to 400 people, over 100 rooms in this building. And again, you know, I think the Americans are great. They let you walk through, and you can take plenty of pictures. They usually have a ranger roaming around. So I monopolised her time for quite a while, asking about various things. I asked them about how much they'd rebuilt, and she said, well, they haven't really rebuilt it, they've just consolidated the stuff at the top. So the loose stone and they're at the top of the walls, they've consolidated that stuff, but they didn't, with the exception of one of the ball courts, which they rebuilt, they haven't done that. So for about 200 years, this place was very prosperous, but then a drought set in, and for about 100 years, there was a very strong drought. And so people just seemed to leave the area, whether they were assimilated into groups like the Hopi and Navajo, I'm not sure. There are some stories about this. It's really interesting to visit. They have a visitor centre there with a little museum section, which is very well signposted, and so you can spend ages there just reading everything. That's why I took so many photos, because I took photos of all the signs so I could read this stuff when I came back to Adelaide. So as I mentioned, by the 1200s, a major drought had come in, and this made it very difficult. So before that time, before the eruption, without that 3 or 4 centimetre layer of ash, it wasn't great for growth as well. So after the eruptions, they started to move in because they realised the material that had been blown out was good for their agricultural purposes. There are 2 ball courts. This is the one that wasn't rebuilt. Incidentally, just walking around the rocks, there's lots of interesting formations. But apparently, this is the furthest north they played these kinds of ball games in their communities as well. As you know, as you go down to Central and South America, ball games were quite popular with various groups. Excuse me. I'm not sure whether these were storage rooms or whether they were rooms that people lived in. As I said, most of it's fairly well signposted, but some of it is sort of got to interpret yourself or read a little bit later. Getting towards the end, my reason there for being in the US, as I mentioned, was for the International Planetarian Society. I've not included a lot of that because we'd be here all night, but in particular I was in this region because of the Lowell Observatory. The Lowell Observatory was built by a wealthy Boston mathematician called Percival Lowell in 1894. This is not part of the original observatory. This is Anderson Mesa, and this is one of their outer observatories. They've got 2 outer observatory sites, because as the city grew, the light pollution grew as well. So the main Lowell Observatory now is not used as much for research as it is education. So it's become a real education centre. And every night I was there, because I was giving lectures every night, there were stacks of people, families that came in, and you get a lot of grey nomads coming through the area and visiting the Lowell Observatory, because it's not only world famous, it's not only locally famous, it's world famous as well. There's the old Clark refractor. This is a 26-inch telescope that was used by Percival Lowell. So Lowell came from a wealthy Boston family, and he spent what would be equivalent now to millions of dollars putting the observatory up on what they call Mars Hill. And it was a very dark site there. I've looked through this telescope a couple of times now. It's beautiful. It's all built from ponderosa pine. So as much as I love this, I'm always worried about bushfires getting up there. They don't seem to have a lot of trouble with fires. You've got rubber tyres, car wheels there, that guides the observatory around, back when it was built in 1894. And Percival Lowell in particular was famed for looking for planet X, so that planet out beyond Pluto, or Pluto itself. He was fascinated with Mars, and he believed there were canals on Mars and there was intelligent life, and he said, look, I can see these canals that must have been built by Martians. And he was pushed on by an Italian astronomer, Giovanni Schiaparelli, who believed he could see lines on Mars, but he wasn't talking about Earth-like canals that were built by humans. And of course, Percival Lowell is buried right next to that observatory. That's his mausoleum. And there's a picture of Percival. The only thing that's changed from when I went there about 25 years ago is they built this glass top on the top. Apparently, and they have Halloween shows up here, and apparently one Halloween, the first frame they had there rusted, and like this red stuff came down when there was a rainstorm one time, which absolutely freaked the kids out apparently. Some kids were running down from there, terrified as a result. They thought Percival Lowell's blood was coming out of the observatory or something. So he's an interesting character. You know, all sorts of things you could say about him. He was an ambassador to Japan, ambassador to Korea in the early days, spoke a number of different languages and so on. This one, we can't leave out the Pluto Discovery Telescope. This is the little dome. So this is at the main observatory. When I went there many years ago, this was painted red, which I assumed was the original colour, and it was kind of looking a little bit run down. But since I've been there, they completely refurbished it and returned it to what its original colour was. And I was very lucky, very privileged to be there for a couple of weeks. The night when I was taking these photos, there were probably 80 people standing outside waiting for a tour, and they basically said to me, you take as long as you want in there. Don't worry about them, take as many photos as you want. So they really gave me the VIP treatment. Essentially, this telescope is like a giant camera, and Percival Lowell, I beg your pardon, Clyde Tombaugh, who used the telescope to discover Pluto, was taking photographic plates, and he used a machine called a blink comparator, which would go from one photo to the other, and it would notice anything that moved, and this was the way he discovered it. So he marched into the office of Vesto Slipher and said, I found your planet X. And as you know, Pluto, much to the annoyance of the Americans, was demoted in 2006, or reclassified. It's still a planet, but it's now a dwarf planet. So it's seen as the large object of the outer material asteroids and so on. When you go to Anderson Mesa, they've got a number of telescopes out there. I haven't put them all in. Telescopes that we use to work out the existence of things like dark energy and dark matter. This particular one, the John Hall telescope, would be a lovely one to have in the backyard. This is the view outside. So this is all part of the Qa'na National Forest. As you can see, it's about 1 metre across. Nowadays, they use it for calculating the rotation of asteroids, for calculating the rotation of comets, and things like that. Also looking at sunlight stars. So there's a lot of research being done at these places. This is their big baby. This was the one I was excited to see. Now this is a fisheye lens. You notice my legs look long and skinny. That's the only way we could fit it into the photograph. I think it's about 26 metres tall. This telescope was built further out again, near a town called Happy Jack. It's about 65 kilometres from Flagstaff itself. This is now the 6th largest telescope in the contiguous United States. It's just amazing to see. And again, they're looking at Apollo crossing asteroids that might be a danger to Earth. They're looking at different types of stars. They can plant a lot of instruments. This whole thing rotates along the bottom. And it's such an all-azimuth telescope, means that it moves like that and moves up and down like that. A very simple design. This telescope cost $53 million to build, and not 1 cent of it comes from the government. All right. All of Lowell Observatory to this very day is not funded by the US government at all. It's all run through donations and through what they can generate for having tourism up there as well. Why it's called the Lowell Discovery Telescope was the founders of the Discovery Channel, I forget their names, they donated $16 million towards this. So Lowell is supported through wealthy philanthropy. This is what we need to see in Australia a lot more, whether it's medicine or geology or astronomy. The Americans do this very, very well with attracting philanthropists. So they built this and it saw first light in 2012. Qa'na Katsina, who was my host there, he actually spent a few years in Australia at Siding Springs Observatory, so he's quite familiar with Australia. He does, I forget his primary research, but they love this telescope. So, you know, it's about $80 million Australian, so 53 US million. And 10 years later, they've just built a new visitor centre, 52 million US. Again, it's all privately funded through philanthropy and so on. And as you can see, our largest optical telescope in Australia is 3.9 metres. This particular one is 4.3 metres. So this is where the public don't get to go. I'm hoping this bit of video will work here. Just and I don't know about the volume here, whether we'll hear it. Let me just see. Turn volume up here. I'll play. It's only a tiny bit of video anyway. So he's just basically.
Here we are at the 4.3 meter Lowell Discovery Telescope outside Flagstaff, Arizona. 4.3 meters is the size of the primary mirror, the diameter. That allows us to collect a lot of light for our scientific instruments. We send the light off the primary mirror up to the secondary and down through the hole in the center of the primary. And on the back side, we have our instrument cube, which has 5 different instruments, imagers, spectrographs, and more, so we can study all different kinds of light, We have planetary scientists who use this. We have stellar astronomers, galactic and extragalactic astronomers, who all use this telescope for their scientific activities.
I took so much bits of video of the equipment and so on with the whole thing. To kind of finish up, when I was very lucky, I was working with Lydia Little. As you can see, she's the multicultural outreach facilitator at the Lowell Observatory's Native American Astronomy Outreach Program. She's a Navajo girl, and they run this wonderful program. They've got about half a dozen people that work in the multicultural side to schools and teach astronomy. We also spent a night at Northeast University doing Native American astronomy, running astronomy for Native American students and so on. But look, I've been very lucky in my experience to be able to go to places like Unadada Aboriginal schools and see the way they teach in the school, and so to go to a Navajo school was really interesting for me as well. And so they were there, this gentleman, he was teaching the astronomy, and they were very strict on face masks, which was interesting, because COVID had mainly passed them, but they were worried about it getting passed on to elders, chiefs and so on. But again, you know, this would be here a long while. The kids really wanted to talk about deadly Australians to me. They were interested in the astronomy, but they were more interested in learning about things that kill you. So they know about Australian spiders and snakes, and they really wanted to talk to me about that, and I spoke to them a little bit about that. When we were driving out there, we passed this sign that said dinosaur tracks, and I got very excited, and I said to her, does that say dinosaur tracks? Because even though I'd seen dinosaur prints in museums before, I'd never seen dinosaur prints in situ, in the bush before. And she said, oh yeah, we're going to take you there on the way back. And I was like, yes. And so we went back, and this was a theropod dinosaur. These were theropod dinosaurs, we think. And so when you walk out into this field here, it is just covered in dinosaur prints, all right? You know, covered, and there's only a small sign. And it's right in the smack middle of the Navajo Nation out near Tuba City. And so I got very excited to be there and see dinosaur prints in situ. The last slides, I think, are of Meteor Crater. I haven't included much of this because, again, I think Meteor Crater deserves a talk in its own right. For those people that don't know, this is the best preserved meteorite crater on the Earth. It's 1.2 kilometres in diameter, about 170 metres deep. It happened about 49,000 years ago, so it's a very young feature. The piece of rock that came and created this was probably about 50 metres or so in diameter, struck the desert at a high velocity and blasted out rock, and here we are. Again, this is privately run. It's not run by the government. It's run by the Barringer Crater, who were part of a mining family, and they bought the rights, and they still run it. And to their credit, they do a fantastic job. They've got a museum set up there. Kyla took me out there, and his little daughter, Meta, she's about, I don't know, about 9 or 10. She wants to be an astrophysicist. And I tell you what, she will. She's such a smart girl. She hangs out at the observatory, so she's going to be very successful, I think, as a scientist in her own right. She was well versed in Australian history because he came and worked here for 3 or 4 years. She did 3 or 4 years of her schooling in Australia as well. So I tried to fool her with the drop bear stuff. No, she wasn't going to swallow any of that. She was well versed on that stuff after living in Australia. There is the Holsinger meteorite. This is the largest preserved fragment from this impact 49,000 years ago. Most of the stuff was vaporised in the initial impact and the release of energy. Members of NIA wrote an article about this. I forget the exact weight of this fragment, but this is the biggest fragment. But when you go through various US museums, there are quite a few fragments from this laying around. Thank you.
So we'll take some questions now.
Don't know if I can answer them, but I'm happy to take any questions.
What's that animal you're holding there?
That skull is of a saber-toothed cat. And so the great thing for me, and I recommend for anyone, is always network with people, network with scientists. And I've been in a privileged position to be able to do that. And so before I went there, I spoke to Diego Garcia Polito, and I said, when I went many years ago, I really wanted to go to the La Brea Tar Pits. Do you know anyone there? Yep, no worries. So he put me in contact with one of the managers there, the scientist, and so the scientist that runs the place, I forget her name, sorry, I've got a mental blank, but she's originally from South Africa, and she took myself and my friends on a 3-hour tour behind the scenes, before, and we met many of the scientists involved, before we even looked at the La Brea Tar Pit Museum itself. So again, I just thought, well, I've probably got a dozen talks for the Field Geology Club, so that's going to be my next talk.
Oh,
Yes.
you seem to have both basaltic lava and obsidian there. Basaltic would have been that lava, the sharp stuff.
It is
Obsidian would have been arrowheads, is that correct?
I don't know what the arrowheads are made from, but it is the type lava, as opposed to the, I think it's Pahoehoe, the other one. So it's similar to the stuff you get in Hawaii. And all I know is the sharp stuff, they say it forms clinkers. They call them clinkers. But it is a basaltic rock, and which is different, you'd know better than I, to things like andesite and rhyolite and other types of volcanic rock. So it's associated with a hot spot, much like Yellowstone, they think, is under that area. So the hot spot apparently is moving towards the east, they say. Yes?
Have any other active volcanoes been discovered on any other planets?
Oh yeah. So the most volcanically active body for its size in the solar system is Io, which is one of the moons of Jupiter. Triton has, when Voyager 2 went out there, has a type of cryovolcanism happening as well. We think there is still active volcanism on Venus, and I've seen various papers where they say no, yes, possibly. And of course, historically, Mars has been active. We think Olympus Mons stopped erupting maybe about 180 million years or so ago. But certainly there's evidence of it, yeah. And even the moon had volcanism at some stages, the volcanic features of the moon as well. Yep.
Are those telescopes generally used for data collection, or are they actually used for looking through? And if so, looking at the night sky, and if so, did you look through them at that time?
So very few astronomers now, professional astronomers, actually look through a telescope. Those days are long past. Everything's hooked up to computers now. Let me just minimise that. And anyway, I'll go back. But most of those telescopes now at Lowell itself, like let me go back to the Clark, you can still look through this telescope. So they run this. So when we were there that night, we had a look at Saturn through this telescope. The first time I was there, we looked at the wild duck cluster, but it's not. Well, don't quote me. I don't know if it's used for research, but I don't think it is. It's mainly used for tourism now. So all of the Apollo astronauts looked through that telescope. Carl Sagan, lots of well-known scientists over the years. But Percival Lowell used it primarily to study Mars, the planet Mars. The other telescopes, like you don't look through the Pluto Discovery Telescope, but they tell you the history of it. Some of the other smaller telescopes I didn't include in this presentation, but they've actually got a round building where they've got other quite large telescopes, and they roll the shed back and take tourists up there, and you look through the telescopes there. But they run magnificent tours, and the volunteers are knowledgeable. You know, they're not as amateurs. I've seen some people when they're giving presentations, they know their stuff. So they do quite well. But most telescopes now are hooked up to computers, and very few of them are used eye-to-telescope type discoveries, mostly used as research type telescopes like this one. You can see a lot of the stuff hooked up there. So they're doing research, but not so much at the main observing site, at the other sites out of town like Anderson Mesa and at Happy Jack out near there. Yeah.
Thank you.
Yes?
Oh, thank you, that was brilliant.
Thank you.
Arizona like that, and realised there were so many of those sorts of places. What was it that made you not go to the Grand Canyon? Because anybody usually who goes to that area, they have to go to the Grand Canyon. Was there a specific reason, or?
Only because when I went to the US 26 years ago, I went to the Grand Canyon with a friend of mine. Absolutely fantastic. If you've been there, you know it's just covered in tourists. Hard to get by the wall even sometimes. And I was planning on going back there. So when I thought I'll go to Sunset Crater. It's probably maybe not going to be that interesting. If I've got time, I'll go to the Grand Canyon again. But I got so fascinated with the Sunset Crater, I didn't bother going to the Grand Canyon. And I'm happy I've been out there once, but that was the main reason. And look, as fascinating as the Grand Canyon is, if I had a choice to go to the tour again, I'd probably go back to Sunset Crater. Because there's so many other Puebloan ruins I didn't look at, and I would kidnap a geologist and bring them with me and say, teach me about the place. Really interesting.
I must be very lucky because as an undergraduate student in England, they took us to Arizona and Colorado, and we had to go and see the Grand Canyon.
Yeah.
And it was pristine.
It
There was
is.
some good interpretation. I went back 30 years later, and because of the number of tourists, it was just a real turn-off.
That's what put me off a bit too.
That's right, the number of tourists. So luckily, as students, we found, there's a crater down there. It's called Sunset Crater. Let's go and have a look. There was no people, nothing stopped us walking to the top of it.
Yeah.
And we had a wonderful time.
Yeah. Well, if I go back, I would go like to ST Crater, place like that where you actually can climb it. It's not that far away, and it's very similar looking to that. And I guess they just want to keep that one pristine because it's part of a national monument. But there, as you know, there are 600 volcanic forms in that area, so there's lots of stuff to climb other than that particular crater. But the tourism did put me a little bit off the Grand Canyon. When I went, it was 1998, the first time. I thought the Grand Canyon is fantastic, but again, I think if I went back to the Grand Canyon, I'd try and key down a geologist or take a tour somewhere you can. And you need time for that and money as well. So, and I didn't have the time. They sort of worked me very hard when I was there. I was giving lectures every day, and that afternoon we had an annular eclipse, so they had me on a telescope. And the funny thing was, people would come in and say, "Okay, all the way from Australia for this," and I'm like, "No, not exactly." But they said that afternoon, have it off, and you go out and look at that.
Any more questions? Okay, I'd like to invite Jaden Squire to the podium to give the
You sure that's wise?
word of
Yes.
Only. Just would like to thank Paul for a wonderful talk. I'm very jealous. I've been to Arizona twice in the last 2 years, but those trips have been strictly confined to the nightclubs of Phoenix. And secondly, a comment on what Paul was saying about the Barringer family. They're one of the most generous families in meteoritics. They paid for all my expenses to go to a conference this year in Perth and have given $2,500 USD towards my PhD project. So as Paul was saying, the dynamics in the US to Australia and how funding is over there, it's largely private, while here it's relying on the government. But what a fantastic talk, and hopefully next time in Arizona I get over my fear of driving on the wrong side of the road. So I can
It's
go
very easy.
So I can go and visit these things. So here's some chocolates on behalf of all of us.
Thank you.
All right, that was a great talk. Thank you very much. We're very honoured to have you as a member of our club. Since 1992, you've been around a while.
Been around. It was all due to Vic Gostin. When I started astronomy many years ago, and also Bob Major a little bit as well, we went to a lecture from Vic on the KT boundary extinction. We thought he was fantastic, a great communicator, as people know. And so we're like part of the Vic Gostin fan club. We said we're going to follow him around and go to all of his lectures. And he said, you should join the Field Geology Club, they're a friendly mob. And that's always been the case. So if you're not a member, I advise you join it. It's a good group, great group.
Okay, well, I'd like to